When we start getting into hypertrophy programs, it will be important that you understand how they are designed and why they will work. The first method we're going to look at is mechanical tension. Now, when you flex a muscle, you create tension within it, and the harder you flex it, the more tension you create. So, when you pick up a 20-pound barbell, you create enough tension to lift 20 pounds. The amount of tension we create is directly related to the amount of force we need to apply. Therefore, when you increase the weight from 20 pounds to 50, the amount of tension needed to move the weight also increases. And this brings us back to our understanding of motor units. Remember that motor units innervate with each muscle fiber. And therefore, the more muscle units we engage, the more muscle fibers we work. And the more muscle fibers we work, the more force that's generated. Here's a simpler way of looking at it. Let's assume a car is broken down and we need to move it out of the way. One person isn't strong enough to move it, so we recruit a second. And if we still can't move it, then we recruit a third person. Basically, we continue recruiting until we can move the car. And this is similar to how motor units work. We keep recruiting muscle fibers until we've recruited enough to produce the necessary force to accomplish a task. We recruit muscle fibers in order from smallest or weakest to largest or strongest. Another way of saying it is that we engage muscle fibers from slow twitch to fast twitch. It occurs in this fashion because we want to preserve muscles that quickly fatigue and rely first on the ones with the stamina. So if we only require 3 people to move the car out of the way, there is no point in wasting the energy of other people to assist in moving it. This is how muscle fiber recruitment works. First, fibers are recruited in order from smallest to largest. But then the recruitment stops once you have enough fibers to produce the necessary force. One of the reasons motor unit recruitment is so important is because the better your ability to recruit large, powerful fibers, the greater the hypertrophy response. So for example, if you could imagine the first 3 muscle fibers in this image doubling in size, the total muscle would be bigger. But if all 5 fibers doubled in size, the muscle would be substantially bigger because the doubled size of the last 2 fibers would be so large. Now, there are 3 ways we can maximize motor unit recruitment. The first, similar to the examples just given, is the load. The second is velocity, and the third is mind-muscle connection. First, let's deepen our understanding of load. When we refer to 1 RM, we are talking about the maximum load we can lift for 1 rep, which equates to 100% effort. 100% effort means that we are recruiting everything available to us to move the given weight. So when we were lifting a load that is 80% of our 1 RM, we are only recruiting the muscle fibers necessary to move that specific amount of weight. So we know the heavier the load is, the more motor units will be recruited. The second variable that we can manipulate to increase motor unit recruitment is velocity. Velocity is simply the speed from one position to another and is measured by mass times acceleration, or the load times acceleration. So how fast you move the weight from the bottom start position of a bicep curl to the top position of a bicep curl is the velocity. Our focus is going to be on increasing acceleration to increase the velocity. Now, let's assume we're doing a bicep curl. If we have a load that is 80% of our 1 RM and curl the weight with an 80% effort, we only recruit roughly 80% of our muscle fibers. In this example, we're using the effort as the gauge for how fast you're trying to move the weight. Now, let's assume we have the same weight, but we are going to give it a 100% effort towards moving the weight as fast as possible during the bicep curl. In order to accelerate the load as fast as possible, your body has to recruit more motor units. Therefore, to move the same 80% of your 1RM as fast as possible, your body could recruit up to 100% of its muscle fibers. Recall this image from earlier? We only needed a limited number of people to move the car. But what if we wanted to move the car quickly right from the start? We can't make the car light, so the only option is to push harder and generate more force. Since each individual is already maxed out, we need to recruit more people to push the car. This is exactly how your body works to increase the velocity of an exercise. Now, the weight itself doesn't need to literally move fast. The simple intent of accelerating as fast as possible increases motor unit recruitment. The third variable towards maximizing motor unit recruitment is your mind-muscle connection. Here is a charted EMG of two muscle contractions. And you can see the first contraction on the left is a much smaller contraction than the contraction on the right. And the same load was used for both contractions. The only difference was the mindful intention of flexing the working muscle as hard as possible. The concept of mind-muscle connection means you're activating a muscle and not just moving the weight. You want to perform a conscious and deliberate muscle contraction of the intended working muscle. You should be able to feel it working and contracting hard. It can be very hard to build a mind-muscle connection with some muscle groups, so it requires patience and persistence. Now, we're going to dig into some of the magical components to mechanical tension and why it's possibly the most important factor in muscle hypertrophy. The hypertrophic response can vary based on the type of muscle action. What this means is that there are three specific actions a muscle can perform. Action number one is the muscle contraction, the shortening. Action number two is the isometric contraction, holding a given position. And action number three is the eccentric, the lowering or lengthening of the muscle. All three have been shown to generate hypertrophy by increasing mTOR. Now, mTOR is a kinase enzyme that links with other proteins to regulate cell function. And mTOR is unique in that it governs cell growth, which is the goal of hypertrophy training. Mechanical tension is also key for long-term results. Often when people reach a hypertrophy plateau, it's because they are underutilizing mechanical tension. It's important to note that you have roughly a 10 to 15 second window where you have maximum recruitment. Those giant fast twitch cells that predominantly run on ATP and creatine phosphate burn out quickly. So it's important that you optimize that window. More strength equals more motor units, which long term leads to greater hypertrophy. Recall this slide from earlier. It's displaying how 80% of your 1RM recruits 80% of your motor units. It actually looks a little more like this. Notice how the biggest, most powerful muscle fibers aren't being recruited. If we can increase motor unit recruitment and tap into those motor units, we can chase an even greater hypertrophy response. This is what it can look like when you increase your strength and engage more motor units. In this example, the opportunity for hypertrophy is clearly much greater. And finally, the last piece of the puzzle is understanding the length-tension relationship. Every muscle has an ideal length, which can increase the force generated for a muscle contraction. If you take a look at this chart, it shows you how muscle tension, being the vertical axis, increases as the muscle length, the horizontal axis, increases. The purple line shows decreasing contractile strength as the muscle lengthens. However, the green line shows an increase in passive tension as the muscle lengthens. And the sum of both tensions produces a greater overall tension and opportunity to generate force. So let me try to give you a more practical example. Let's take a look at how passive tension contributes to potential force production. Take your bicep, for example. For the sake of keeping this simple, imagine it as a given length from the top of your humerus to the base. When we remove your bicep from your arm, it actually shrinks and reduces in length. This occurs because it is partially stretched, like an elastic band, between the points of origin and insertion. This is defined as the length-tension relationship and what allows for greater force production from a fully lengthened position. Let's review over the key takeaways of mechanical tension. Mechanical tension may be the most important factor in exercise-induced hypertrophy, and one of those reasons is because of its impact on mTOR. Now, we want to maximize force to increase motor unit recruitment, which then will maximize tension, and that will help us build muscle over the long haul. And finally, you want to favor a full range of motion to maximize the length-tension relationship, which helps with force generation.